So here I'm asked to write 6,324 correct to the nearest thousand. So the way that I like to go about looking at questions like this is to take 6,324 and look at the two ways that it could be rounded. So its closest thousands are we round down to 6,000, or alternatively we'd round up to 7,000. Now we can see that the difference between 6,324 and 6,000 is just going to be 324. However, if we were to round up, it's going to be a lot greater, so it's going to be 676 if we were to round up. And then obviously this value here is going to be smaller, and we're looking for the closest thousand, so we would round down in this case to 6,000, and that would get us the correct answer here. Alternatively, we could look to the number to the right of the 6. In this case, we have the integer 3. And as 3 is less than 5, we're going to round down, so we're going to keep it as 6,000. However, if it was 5 or greater, so if in this place in the hundreds column the number was 5 or greater, we would then round up, and that would cause it to go up to 7,000. So here I'm asked to write the following numbers in order of size, starting with the smallest number. So as we can see here, we've got some negative numbers, 0, and then some positive numbers also. So starting with the smallest, well, it's going to be negative. And in order to determine the smallest negative number, we're basically looking for the one that's furthest away from 0. And in this case, that's going to be -6, as that's further away from 0, 6 away from 0, as compared to -5, which is only 5 away from 0. So -6 is going to be the smallest, followed by the other negative, which is -5. And then we have 0 and 2 positives, so 0 is going to be the next greatest. And then looking at the positives, we have 12 and 6, and 12 is going to be greater than 6. So in order of size, we're next going to have 6, and we'll follow that with the last one, which is 12. I'm then asked to write the following numbers in order of size again, starting with the smallest number. However, this time we're working with decimals instead. So I'm going to be looking at the decimal places here. So the first decimal place, we're going to start with of each number. We have a 0 here, a 7, an 8, and another 7. So in order to find the smallest number, we're looking for the smallest first decimal place originally, which we have here is going to be this, as the first decimal place is a 0. So this one's going to be first 0.078 is going to be the smallest. And then moving on to the next one, we have 3 to choose from, so we've already used this one. Now, both of these have the next smallest number as the first decimal place, so 7. And in that instance, we're going to be looking to the next decimal place, so the second decimal place. Here we have 8, and here we have 0. So the one with 0 is going to be smaller. So I can write in 0.708 as the next smallest, followed by 0.78. And then finally, we're going to have 0.87, as this has the greatest value in the first decimal place of the number. Here I'm asked to write 20% as a fraction. So there are a couple of different ways you could go about thinking about this question. But firstly here, I'm going to look at 20%, and if we're thinking about percentages, it's going to be 20% out of a possible total of 100%, as that's the maximum percentage you could have of some kind of value. So if it's 20% out of 100%, we can simplify this fraction. So we can divide both the top and the bottom by 10 to get us 2 over 10. And then we can simplify this again by dividing both the top and the bottom by 2. And that is going to give us an answer of 1 over 5. So we divided both the top and the bottom by 2 here. And that is going to give us 20% as a fraction. Alternatively, if we were to write 20% as a kind of multiplier in this sense, we have 0.2, which again would give us a fifth as a fraction. 0.2 out of 1 is equal to a fifth. So either way that we go about doing this question, we're going to come to this answer of 1 over 5. So here we have a list of 4 fractions, and they're below. And then we're told that one of these fractions is not equivalent to a quarter, and we're asked to write down this fraction. So the word equivalent basically means it can't be simplified to a quarter. So we need to find the fraction here which can't be written as a quarter in its simplest form. So the way that I'm going to go about doing this, it may instantly jump out to you which fraction it's going to be, but if we need to go through and calculate it, I'm going to take each fraction, so starting with 4 over 16, and to get it in its simplest form, if I divide by the numerator over the numerator, it's going to give us a fraction of 1 over something, and we can see if this is a quarter or if it's not a quarter. So in this case, if I divide by 4 over 4, which is just the same as dividing by 1, so it doesn't affect the fraction, it's just simplifying it. And that's going to give us an answer of a quarter, so it's not going to be 4 over 16. Similarly, with 2 over 8, if I divide by the numerator, so 2 over the numerator, it's also going to give us an answer of a quarter. And with 15 over 60, divided by 15 over 15, similarly gives us a quarter. So now we're hoping that it's going to be the 3/9 that is not going to give us an answer of a quarter by process of elimination. So if I do the same thing again, divide it by 3 over 3, this time it's going to give us a third as an answer. And under no circumstances can a third be equal to a quarter, as both of these are in their simplest form. So the answer here of which fraction is not equivalent to a quarter is going to be 3 over 9 in this instance. Here I'm asked to write down the first even multiple of 7. And this question's simply worth 1 mark, so we're just asked to write it down. There's not going to be any calculation really involved here. So a quick way to do this, and quite an efficient way, would just be to write out a couple of multiples of 7 and see which one is the first even one. So the first multiple of 7 is 7 times 1, which is 7. And then the next multiple of 7 is 7 times 2, which is going to be 14. And we can see here that 14 is even, and it's going to be that first even multiple of 7 that we come to. A way of looking at this is we have 14, which is going to be 7 multiplied by 2, and 2 is even, and an even multiplied by an odd is going to get us an even, and we have 7 here, which is just 7 times 1, and that's going to obviously be odd here. So once we've multiplied 7 by an even number, the first even number that we multiply it by is going to be 2, and that's going to get us the first even multiple of 7. So that's going to be 14. Here I'm asked to simplify 3 multiplied by 4t. Now when we're working with an unknown variable like t, and we've got 4 lots of it, we can simply multiply this 4 by the 3, and then we're going to have an answer in terms of t. So we just simply do 4 times 3 times t. We could split this 4 times t into 4 times t. That's basically how it's written. And that's going to bring us to an answer of 4 times 3, which is 12, multiplied by t, so 12t here. Similarly, we could look at this as though we've got 3 lots of 40. So we have 40 plus another 40. And that's going to get us 12t in total, because we can just add these together. The same sort of idea here, we're asked to simplify again 8a minus 3a plus 2a. So in terms of adding and subtracting, we can just add and subtract the numbers and forget about the a kind of until the end, and then bring that back in because it's an unknown variable and each of them are in terms of a, so we can just simply add and subtract them as we would normally. So 8a minus 3a firstly. Bid Maths here says that we can do it in any order. We can do the addition or subtraction first and it will get us the same answer. So 8a minus 3a is going to be 8 minus 3, which is 5a. And then we're going to have this 5a and we're going to add on this 2a at the end. So 5 plus 2 is going to give us 7a. So the answer to this one is going to be 7a. So in this question, we have a probability scale, and it shows the probability of each of the events A, B, C, and D, which we can see on the scale in these places. And firstly, we're asked to write down the letter of the event that is certain. So it's a good idea just to make sense of the probability scale, see what it's showing us exactly. So if we have a probability of 0, we're working with the range of 0 up to 1 here. So a probability of 0 is telling us that there is a 0% chance of it happening. This event cannot happen, and a probability of 0 here is going to be impossible if there's no percentage or just no chance of it happening. As we move up the scale then, it's going to get more and more likely until we get to a half here, which could basically be equated to a 50% chance of it happening. So it's equally likely to happen as it is to not happen. And then we get increasingly and increasingly more likely until we have a probability of 1 here, which may make it easier to write as 100%. So this has an 100% chance of happening. It is definite that this event will occur. So reading the question again, we're asked to write down the letter of the event that is certain. With an 100% probability, this event is definitely going to happen, so the event that is certain is going to be this point here, which is D. And now we're asked to write down the letter of the event that is unlikely. So in this case, we're not going to be working with A here, as A is going to be impossible. There's a probability of 0. We have the 50% here, and would assume that an unlikely event is going to be less than 50% likely, because anything above 50% is more likely to happen than it is to not happen. So in between the 0 and a half here, we're going to have point B, which does sound about right to be unlikely because it's not impossible, it's not at the 0, but it's less than this 50%, so it's more likely to not happen than it is to happen. So for this one, I'm going to go for option B. And here we're told that there are 12 counters in a bag, 3 red counters, 1 blue counter, and 2 yellow counters, and then the rest of the counters are green. Caitlin takes at random a counter from the bag, and we're told to show that the probability that this counter is yellow or green is going to be 2/3. So the thing that's jumping out to me here at first is going to be the fact that we have the number of red, blue and yellow counters, but we haven't been told the number of green. So we have a total of 12 counters in the bag, and if we have 3 red, 1 blue and 2 yellow, the rest are green, we can work out the number of green counters. So the number of green counters, we can take the total of 12 and subtract what we already have. So 3 red minus 1 blue minus 2 yellow. And that is going to give us an answer of 6. So there are 6 green counters. And now we're asked to show the probability that this counter, this one random counter that she picked out of the bag of 12 counters, is either yellow or green. So we can add together the number of yellow and green counters there are in the bag. So if we do yellow plus green, we have 2 yellow counters, and we've just worked out there are 6 green counters. So there's going to be 8 yellow and green ones in total. And then the probability of choosing one of these yellow or green counters is going to be this value of 8, and it's going to be out of the total number of counters in the bag, which in this case is 12. And then if we simplify this by dividing both the top and the bottom by 4, we're going to come to this answer of 2/3, and that's the value that we were asked to show in the question, and the probability that this counter is yellow or green is going to be 2/3 as required in the question. So here I'm told that 3 kilograms of meat costs £54 and that Nina buys 2 kilograms of meat, and we're asked to work out how much Nina is going to pay for this. So a good way to go about these types of questions is to scale it down, and in this case I'm going to work out how much 1 kilogram of meat would cost in order to multiply this up and work out the cost for 2 kilograms of meat. It's just a little bit easier than working with kind of 3/2 and fractions in this instance, although you could do it that way either. So I'm just going to rewrite the information out in a bit of an easier way to understand. So 3 kilograms is equal to £54. Now if I'm trying to find 1 kilogram here, I can divide both sides of this equation by 3. So I'm going to have that 1 kilogram of meat would cost 54 divided by 3, which is giving us an answer of £18. So now that we've worked out how much 1 kilogram costs, I can then multiply this up by a factor of 2 because I want to work out how much 2 kilograms costs. And that is going to be multiplied on this side of the equation also. So 18 multiplied by 2 is going to give us an answer of £36. And that is the answer to the question. We've worked out how much it's going to cost for Nina to buy this 2 kilograms of meat. So £36. Alternatively here, you could do this in one go, and you could go straight from 54 to the 36, and you could go straight from 3 kilograms to 2 kilograms by dividing by 3 and multiplying by 2 in the same go. So you'd multiply by 2/3 on both sides of the equation, and that would take you straight to the answer with just one less step throughout the question. So here we're told that the centre of the circle is marked with a cross, X, so this point is going to be the centre of the circle. And then we're asked to write down the mathematical name of the straight line which is shown in the circle, so this straight line here. So if we just make sense of the diagram, if the point X is going to be the centre here, and then this point here is going to be a point on the circumference of this circle. So we have a line going from the centre of the circle, touching the circumference of the circle, and this is going to give us the radius of this circle. Now if we were to have a line going from a circumference through the centre to another point on the circumference, that would be the diameter, but this point is simply going from the centre to the circumference to any point on the circumference, so it's going to give us the radius of this circle. Similarly, this line could be drawn in here and still give us the radius. It could be drawn in at any point from the centre to the circumference to give us the radius of the circle. We're then asked to write down the mathematical name again of the straight line that is touching the circle. So this time we have a straight line which is touching the circle at a singular point, which we can mark on here. So the way that I like to remember the name for this is it's touching the circle at one point. The T at the start here reminds me of the T at the start of the word to describe this, which is going to be a tangent to the circle. So it touches the circle at one point on its circumference and is a straight line. So that's just how I like to remember the names for these couple of different parts of a circle. So here we're told that Tim and 3 friends go on holiday together for a week. The 4 friends will share the costs of the holiday equally. So the total cost is going to be split between these 4 friends. And then we have the costs of the holiday. So £1,280 for the 4 return plane tickets, £640 for the villa, and then £220 to hire the car for a week. We're not too concerned about what this money's spent on, we're just going to be using it to work out the total money spent. And now we're asked to work out how much Tim has to pay for his share of the costs. So we're just going to be working out his share of what he's going to pay, which is going to be split between the 4 friends. So Tim is going to be paying a quarter of the total costs. So now we just need to work out what the total cost is so that we can multiply it by a quarter or divide it by 4 to work out how much each of the individuals are going to be paying, so how much Tim's going to be paying. So if we take all of the costs that we have, so we have the £1,280 for the tickets, the £640 for the villa, and the £220 for the car hire, and we add them all together to get the total cost, that's going to give us a total of £2,140 for the holiday. And then if we're going to take this 2,140 and multiply it by a quarter, so divide it by 4, that's going to give us each person's share, and that means that Tim is going to be paying £535 for the holiday. And that's going to take us straight to the answer, and that's going to be a quarter of the total cost, so what Tim is paying. So here I'm asked to write down an example to show that each of the following 2 statements is not correct. And then the first statement here is that the factors of an even number are always even. So we're basically looking for an example that's going to disprove this. We're looking for an even number whose factors are not all even. So the way that I started thinking about this question is if we take an odd number and multiply it by any even number, we're always going to get an even result. Now this kind of statement here is already disproving the fact that the factors of an even number are always even, because if we take any odd number, I'm going to go with 3, and then an even number, which I'll just take as 2 here, then that's going to give us an even result of 6. So we've taken the factors of 6, which is an even number, and its factors are 3 and 2, so one's odd and one's even, so this shows that the factors of an even number are not always even, as there's an odd here. So then, to get the mark, I'm just going to write out that 3 multiplied by 2 is equal to 6. And now I'm looking for an example to disprove the fact that all the digits in odd numbers are odd. Now this one's arguably a little bit easier to go about, and if you think that every other number has to be odd, if we were to start a number with an even number, so if we took a 2-digit number and started it with an even number, such as 2, then there are going to be 2-digit odd numbers that start with a 2. So we've got 21, 23, 25, 27 and 29. So I could just take 23 as an example here. And then we have the 2, which is even, and the 3, which is odd. 23 is going to be an odd number, however, one of its digits is even, so the 2, and one of its digits is odd. So we've just there come up with an example that shows that this is not always correct. So here we're told that a shop sells desktop computers, laptops and tablets, And we have a composite bar chart which shows information about sales over the last 3 years. And then below we have the bar chart. So on the y-axis here, we have the number of each thing sold, which we can read off from this axis. And then on the x-axis, we have the years in which these things were sold. And then the bars above them correspond to the number of each thing sold. So 2015, and then this is going to be the bar from which we can read off of the y-axis how many of each were sold. We can use the key over here to determine what each shading region is going to correspond to. So the black shaded region is giving us the numbers for desktop computers, the diagonal lines are for laptops, and then the grey shaded region is for tablets. So now if I go on, I am asked to write down the number of desktop computers sold in 2015. So initially here I'm looking at the year 2015, so I'm going to be looking and working with this bar. And then I'm looking for desktop computers, which are represented here by the shaded black region. So I basically need to work out how many computers this region of the 2015 bar represents. So if I trace the top and bottom of the bar across to the y-axis, it's going to start here at 0, and it's going to go up to somewhere in between 95 and 100, basically 100 here. So if I work out the difference between these two, I'm going to get an answer in between 95 and 100. So here I'm just going to go for something like 97. And we would get the mark for anything in between 95 and 100, because that's going to be the height of this bar, which represents the number of desktop computers. So here I'm asked to work out the total number of laptops which were sold in the 3 years. So I'm basically here looking to add up the heights of the bars that represent the laptops over the years 2015, 16 and 17. So I'm going to add these up and cut to a total, which is going to be the total number of laptops. So if I read off the heights of these bars, so in 2015 we're looking for laptops, so that's going to be this white background with the diagonal black lines, and the bottom of the bar is going to be at 100, and the top of the bar is going to be up here, which is at 260. So because the distance between for every increment of 100 is going to be 5 little squares, and it represents a change of 100. If we do 100 divided by 5, we're going to get 20. So each little square is going to represent 20 things sold. So we can count up the little squares in 20s. So we have the 260 at the top of this bar. So in 2015, the total number of laptops sold is going to be the top of the bar, so 260, minus the bottom, which is at 100. So that gives us 160. And then moving on to 2016, we're going to apply the same sorts of ideas here. If I draw the line across from the bottom, this is going to be at 120. And then the top of the bar here is going to be at 340. So I can do the same thing for 2016. I can take the top of the bar at 340 and subtract the bottom, which is at 120, to get an answer of 220 for the number of laptops sold in 2016. And then finally for 2017, so we have here 160 at the bottom and 440 at the top. So for 2017, I'm going to do 440, subtract 160, and that's going to give us an answer of 280. Now, if I want to work out the total number of laptops sold over the 3 years, I can take each of the individual ones from the 3 years and add them up. So 160 plus 220 plus 280. and that is going to come out as an answer of 660. So 660 laptops have been sold in total over the 3 years. Now, to gain the marks here, you're going to get the first mark for basically reading off 3 of these values from the graph correctly. So if you've read off 3 correct values, you're going to get 1 mark. The second mark is going to be adding the totals together of the bars, and then the third mark is for simply getting the correct answer at the end. I'm now asked to state the item that had the greatest increase in sales over the 3 years, and I'm asked to also give a reason for the answer. So this question is worth 2 marks, so I'm going to get the first mark for stating which item it is, and then the second mark for my explanation behind it. So I'm looking at the bars here in the bar graph, and if I'm looking for the greatest increase in sales, I'm looking for as I go up the years, so from 2015 to 2017, I'm looking for a certain colour of bar to increase in size. So if I look here, the biggest and clearest increase in size is going to be in the grey bars. So we have a much shorter one in 2015, it's growing to a greater size in 2016, and then it's much taller in 2017. So I can see this really big increase in sales. So this is all going to relate to the sales of tablets. So if I write in firstly that it's going to be the tablets, I'm going to gain that first mark, and now I'm looking for a reason to support my answer. So if we're looking in the increase in size in these bars, we could go in with some figures, do some calculations and say how much they've increased by each time. Or here I could simply say that the reasoning behind my idea of tablets is that the bars simply get proportionally longer over time. So they're getting proportionally longer over the years, and they are getting, this is due to this greatest increase in sales. Here I'm told that Alex says in 2017 more tablets were sold than desktop computers, and that this means that the shop makes more profit from the sale of tablets than from the sale of desktop computers, and we're asked whether Alex is correct, and we must justify our answer. So it's only worth 1 mark here, so we're going to have to get the correct answer, whether it's a yes or a no, and give our justification to get this mark here. So if we're looking at the profits from the sale of tablets, if I refer back to the graph, we are basically given the number of each sold. And yes, more tablets were sold than desktop computers in 2017, but the graph has no relationship. It doesn't tell us anything about the costs or profits made on certain sales. We don't know the prices, and we don't know the individual profits made on tablets compared to desktop computers. We can't use the information that we've been given to come to a conclusion here. So when we're asked whether Alex is correct, we can't be sure he's correct, so no, he is not correct, and that's because we don't know the costs or the prices or profit made on the tablets and desktop computers. So I need to write basically this down to get this 1 mark here, and that's going to be enough justification to back up our point that Alex is not correct in this case. So here I'm told that a piece of wire is 240 centimetres long, and then I'm told that Peter cuts 2 45 centimetre lengths off of the wire. He then cuts the rest of the wire into as many 40 centimetre lengths as possible. And we're asked to work out how many 40 centimetre lengths of the wire Peter cuts. So sometimes with questions like this, I find it helpful to draw out a bit of a diagram. So if we have a wire which is 240 centimetres, and then he's going to cut 2 lots of 45 centimetres off the wire. And that's just going to leave us with the shorter section over here to the right. Now we need to work out how many 40 centimetre lengths that we can cut this section into. So when we divide it by 40 centimetres, how many can we cut it into? So firstly, I need to work out how long this remaining section of the wire is. And I can simply do that by taking the 240, so the total length, and then subtracting these two lots of 45 that have been cut off. And then that's going to leave me with an answer of 150 centimetres. So the question is really asking us, how many 40 centimetre lengths can he cut out of 150 centimetres of wire? So in order to find this out, I'm going to take the 150 and then divide this by 40 to see how many 40s go into 150. And if we put that into our calculators, that gives me an answer of 3.75. So theoretically, he'd be able to cut this remaining piece of wire into 3.75 of these 40 centimetre lengths. However, that means that we're going to have 3 that are 40 centimetres and then 1 which is not quite 40 centimetres. And the question's asking how many 40 centimetre lengths of wire he can cut. So here, we're going to have to round down to an answer of 3 lengths because he isn't going to have quite enough to cut 4. However, he is going to have too much to cut 3, but because it's not enough for another length, we can't include this in our answer. So the final answer for this question is going to be 3 lengths of 40 centimetre wire. So here we're told that Gavin, Harry and Isabel each earn the same monthly salary. So each month Gavin saves 28% of his salary and then spends the rest of it. Harry spends 3/4 of his salary and then saves the rest of it. The amount of salary Isabel saves to the amount of salary she spends, so the ratio saves to spends, here is 3:7 as a ratio. And we're asked to work out who saves the most of their salary each month and showing how we get to our answer. So initially here I'm thinking we've got these percentages and fractions and ratios and they're all in different forms. In order to compare them properly and be able to really see a link between them, we're going to have to convert them into the same form. So we could either choose to convert them all into percentages or into fractions or some kind of ratio, or we could even assign a value for the salary and then work out these percentages and fractions as a part of the salary. But I think an easy way here to work with it is we already have 28%, and these other ones are going to be quite easy to convert into percentages. So just to save us a bit of work, if we work with percentages for the savings, then we might come to our answer a little bit more quickly and concisely. So firstly, if we have Gavin and we want to work out how much he saves, and we already have that here, so he saves 28% of his salary. So we can just write that out to remember that for later. Now if we want to work out how much he saves in comparison to Gavin, well, if Harry spends 3/4 of his salary and saves the rest, the amount that he saves is going to be 1 minus this 3/4, so the leftover here. And that's going to give us 1/4, which as a percentage is going to give us 1/4 multiplied by 100 is going to give us 25%. So Harry saves 25% of his salary. And then Isabel, finally, this one's a bit harder, so we're working with a ratio. So if it's a ratio of 3:7 saves to spends, the amount that she saves here is going to be this 3 out of the total of the ratio. So we're going to add the 3 and the 7. So 3 out of the total, which is 3 plus 7, gives us 3 out of 10, which if we convert this to a percentage, we could multiply it by 10 over 10, and that's going to give us 30 over 100, which gives us it as a percentage. So that's going to be 30% that Isabel saves. And then if I refer back to the question, work out who saves the most of their salary. Here we can obviously see that we're looking for the highest percentage, and that is, in this case, is going to be the 30% from Isabel here. So we're just going to conclude and get the final mark by stating that the answer to the question is going to be Isabel, as she saves the most. So the highest proportion of the percentage. And then it would be Gavin up here with 28%, as that's just slightly less than 30. And then finally Harry with a much smaller 25% of his salary. So it's really important that we go through each step of the working, convert these into the same form. So we've gone for percentages here, and then making that conclusion as well at the end based on our data is also very important here. So in this question, I'm asked to work out 15% of 160 grams. So instantly here, when I've got a question working with a percentage of a value, I'm instantly thinking that I'm going to be working with multipliers and working with these multipliers in order to find this percentage of this value. So I'm going to be multiplying 160 by a multiplier to work out 15% of it. So if I'm working out 15% of it, 15, I can use the multiplier here of 15% divided by 100. So that's going to give us a multiplier of 0.15. So that's basically the same as having 0.15 out of 1 is equal to 15 out of 100. So that's 15%. So 15% as a multiplier is 0.15. And then I can simply multiply this, so the 0.15, by the value of 160 in order to work out 15% of 160. And that's going to give us an answer of 24 grams. Similarly here, if I wanted to go about this in a different way, I could work out 1% of 160 and then multiply this up by 15 in order to get 15%. Sometimes that way might make a bit more sense in your heads, and that's totally fine. So 1% of 160 is going to be 160 divided by 100. And that's going to give us an answer of 1.6. And then we can multiply 1.6 by 15, as this one's equal to 1%. This one's going to be equal to 15%, and that gives us 24 as well. So either way about going about that question is going to get us to the same answer of 24. So here we're told that P is going to be equal to 4x plus 3y, and then we're given the values for x and y. So x is 5 and then y is minus 2 here. And then we're asked to work out the value of P. So we're basically going to be using these values of x and y that we've been given and substituting them into the equation for P in order to obtain this value of P. So here, if I write out that P is going to be equal to 4 lots of x, so we can multiply 4 by whatever x is, and I can see in the question that we've been told x is equal to 5. So 4 multiplied by 5, that's the 4x part, and then we're going to be adding on 3y, so 3 multiplied by y, and then y here is minus 2. So 3 multiplied by minus 2. I've just written them out separately so we can see a little bit more clearly what's going on. But then if we multiply 4 and 5, we're going to get 20. And then we're going to add 20 onto 3 multiplied by minus 2 is going to get us minus 6. So 20 plus minus 6 is the same as 20 minus 6. So that's going to give us an answer here of 14 for the value of P. And that is going to get us both of the marks here for working out the correct value for P. Now I'm asked to expand the brackets 4e multiplied by, in brackets, e plus 2. So a way that I'm going to look at this is that we're going to multiply the 4e by the e to begin with, and then we're also going to have to multiply the 4e by the 2 to expand this bracket. So here I'm basically going to have 4e multiplied by e, and then I'm adding on 4e multiplied by 2. So I'm multiplying 4e by the first term in the bracket, then adding on 4e multiplied by the second term in the bracket here. So then if I multiply these out, 4e multiplied by e is going to give us 4e squared, and then 4e multiplied by 2 is simply going to give us 8e. And then we have expanded out those brackets, so I can just put this answer in the box. So 4e squared plus 8e is going to get us both of the marks here for expanding, multiplying out this bracket. So here we're asked to solve 3 lots of m minus 4 is equal to 21. So I'm just going to rewrite the equation that we're given. And here we're looking to isolate m. So we're trying to basically get m on its own on one side of this equation. So a good place to start here is we have this three lots of this bracket. And if we want to kind of isolate the bracket on its own, we can divide both sides of the equation, because we have to do the same to each side of our equation. If we divide both sides by 3, we're going to be left with m minus 4 is equal to 21 divided by 3, so 7. Making sure we do the same thing to both sides of the equation here is very important. So we've divided the left-hand side by 3, so we've also got to divide the right-hand side by 3. Now we have m minus 4 is equal to 7, and if we simply add 4 to each side, we're going to be left with just m on the left. So we have m minus 4 plus 4 is going to be m, and then 7 plus 4 is going to be 11. So here we've isolated the value for m, which is going to be 11 in this case, and that's going to get us both of the marks for this part of the question. So here we're told that there are some chocolates in a box and that a quarter of the chocolates contain nuts. And we're also told that the rest of the chocolates do not contain nuts. And we're asked to write down the ratio of the number of chocolates that do contain nuts to the number of chocolates that do not contain nuts, and to give our answer in the form of 1 to n. So if I refer back to the question here, the ratio 1 to n is going to be basically the ratio of nuts to no nuts. So the ratio where nuts is 1 and no nuts is some value n. So if we have a quarter of the chocolates containing nuts, then we know that the ratio here of nuts to no nuts is going to be a quarter to however many don't contain nuts. And if a quarter contain nuts and the rest do not contain nuts, we can do 1 minus a quarter to work out how many don't contain nuts, and that gives us 3/4. So 3/4 of these chocolates do not contain nuts. So I can put that fraction here. So now we have the ratio a quarter nuts to 3/4 no nuts. And if we want this in the form of 1 to n, like it says in the question, we can simply multiply both sides of this equation, this ratio, by 4. And if we do the same to both sides here, we're going to get a ratio of 1 to 3. So we're multiplying each side by 4 and getting rid of the denominator here. So now we have a ratio of nuts to no nuts, which is what we're asked basically for in the question. And for every 1 nut, there's going to be 3 no nuts. And basically that gives us a value for n, which is going to be 3 in this case. So n is equal to 3. So the ratio here is 1 to 3. So here I'm told that A is equal to multiples of 5 between 14 and 26. And then B is going to be odd numbers between 14 and 26. And we're asked to list the members of A union B. So basically, we're working with A union B, and if we draw a Venn diagram out and call this circle A, this circle B, then A union B is going to be this whole region here. So anything that is A or B, we're going to be including in this list of members, as we're working with A union B. So it's the union of A and B. So if I list out all of the members of A up the top here and all of the members of B, I can then put these together, making sure I don't repeat any, and put them together in a list. And that's going to be this list of members of A union B. So for A, the multiples of 5 between 14 and 26, well, we have 15, 20, and 25. They're the multiples of 5, the three multiples of 5 between these two values. And as for odd numbers, we have 15, 17, 19, 21, 23, and 25. Now, as you can see, we do have a couple of doubles here. So we've got two lots of 15, and then we have two 25s here. So we're only going to write one of these in the list because these would be in this section of the Venn diagram, as they're both members of A and B. So when I'm writing out the list, I'm going to take 15, 17, 19, then 20 from the A part, moving to 21, 23, and then finally 25. So that way's made sure that I've gotten all of the members of A union B, but not counted the intersect of A and B. So this middle section here, I've not counted these numbers twice. And I'm now asked to describe the members of A intersect B. So this time I'm working with the intersect of A and B. So if I draw out another Venn diagram with A and B, the intersection is going to be the points where A and B cross over, so where they overlap. And I've spoken about this in the previous question, so they're going to be the values which are both members of A and of B. And I've already got them circled up here, so we have the 15 that overlaps, which is a member of A and B, and then the 25 also. So the members of A intersect B for this question are just going to be these two values. So we have 15 and 25, as they're both members of A and B. So here we're asked to work out 2 1/7 plus 1 1/4. So here we're working with two different fractions, and these fractions are mixed numbers because they contain numbers and then a fraction as well. So when we're adding these mixed numbers together, we can kind of take the number part and the fraction part and work with them separately. So if I look here, we have 2 1/7 plus 1 1/4. So basically, in this calculation, we're going to be doing 2 plus 1 plus 1/7 plus 1/4. And that just helps work it out a little bit more easily, because we can take the 2 plus 1, bracket that, and then we can add these on separately. So we can do the 2 plus 1 to get 3. So it's basically going to be 3 plus 1/7 plus 1/4. And now we just need to add 1/7 and 1/4, and then we can leave the answer in the form of a mixed number, 3, and then a fraction. So to add 1/7 and 1/4, these two fractions have different denominators. So we're going to be looking to convert them into a similar form so they have a common denominator so that we can add their numerators. Now, in order to do this, we need to find the lowest common multiple. So the LCM of the denominators, so 7 and 4. And in this case, it's just going to be 7 multiplied by 4, because there's no lower common denominator of 7 and 4. So 7 multiplied by 4 is going to be 28. So this is going to be the common denominator that we work with. So I can then take this common denominator, and if we have 1/7 and we need to multiply that by something to get 28, we've multiplied it by 4 over 4. So 1 multiplied by 4 is going to give us 4. And this side's also multiplied by 4. So we have 4 over 28. And then a quarter is equal to, we've multiplied that by 7. So we're going to multiply the top by 7 as well. And that gets us 7 over 28. So to add a 1/7 and a quarter, we're going to basically add 4 over 28 and 7 over 28. And because we've got common denominator of 28 here, we can simply add the numerators. So 7 plus 4 to get us 11 over 28. And then if we look back, we've got this original 3 that we need to add on as well. So the final answer here is going to be 3 and 11 over 28. And that's going to be the answer written in the form of a mixed number. We could convert this into an improper fraction, a top-heavy fraction, but this is still going to get us both of the marks here. We gain the first mark for the majority of the working out, so converting the fractions, and then the final mark for getting the correct final answer here at the end. I'm now asked to work out 1 1/5 divided by 3/4, and I'm also asked to give my answer as a mixed number in its simplest form in this question. So firstly, I can see here that in the question I have a mixed number, and I'm going to be dividing this by just a normal fraction. So it's probably a good idea here to start by converting this mixed number into a simple fraction, which in this case is going to be an improper fraction. So if we have 1 1/5 and we want to convert that into an improper fraction, if we have a integer of 1, we have basically 5 over 5. So that's going to be 1. And then we can add on this 1/5 as well. And that's going to get us 6 over 5. So 1 1/5 is basically equal to 6 over 5, and that's an improper fraction. And so now we have 6 divided by 5, and that's going to be divided by 3/4. Now when we're dividing a fraction by another fraction, we can just multiply this fraction by the reciprocal of the second fraction. So 1 over whatever the second fraction is. So that in this case is going to give us 6 divided by 5. And then we multiply that by the reciprocal of 3/4. So we swap the denominator and the numerator, and we get 4 over 3. And now we've got a simple multiplication to work with. And when we're multiplying two fractions, we can just multiply the numerators and the denominators separately. So 6 multiplied by 4 is going to be over 5 multiplied by 3. So that leaves us with 24 over 15. Now, if we look back to the question, it's asked us to give our answer as a mixed number. And here we have our answer as an improper fraction. So we're going to have to convert this improper fraction into a mixed number. Now, if I look at how many lots of 15 go into 24, we have one lot of 15 and then a remainder which is going to be 24 minus 15. And then that's going to be over 15. So that's how we're going to convert this improper fraction back into a mixed number. So we have one lot of 15 and then this remainder of 9, which is going to be out of 15. So 1 and 9 over 15. And we also need to check that this is in its simplest form. So do 9 and 15 have any common factors which we could use to simplify the fraction? And yes, in fact, they do have a common factor, which in this case is going to be 3. So if we divide the top and the bottom of the fraction we have here by 3, we're going to be left with 1 and 3 over 5. And that is going to be the correct answer and gain us the second mark, which is for the answer. And then the first mark is going to be for the working out and the correct working out stages throughout this question. So here I'm told that in a village, the number of houses and the number of flats are in the ratio 7:4. And we also are told that the number of flats and the number of bungalows are in the ratio 8:5. We are then told that there are 50 bungalows in the village, and we're asked how many houses there are in the village. So with a ratio question like this, we're working with a couple of different ratios between a couple of different places. So it's a good idea to kind of get them all into the same place and write them out in a little bit of an easier way to comprehend and see instantly. So if I write out that we have houses to flats, and we can see at the start of the question that this ratio is 7:4, so 7:4. And then here I can see that we have flats mentioned again, but this time they're in a ratio with bungalows. So if I write this out beneath it, we have here flats in the same column as flats were before to bungalows. And then this ratio was 8:5. And since we're told that there are 50 bungalows in the village and we're working out how many houses there are, we're looking at the houses and bungalows here, and we're going to be looking at the ratio between these. And we can use the number of flats in each ratio to work out the ratio between the houses and the bungalows to then work out how many houses there are when there are 50 bungalows in the village. So here I can see that between the 4 flats and the 8 flats in these ratios, this ratio between houses and flats can be multiplied by 2 to get a ratio between houses and flats in which flats are going to be the 8 here. So we can multiply this by 2. Just multiplying up the ratio by a factor doesn't affect the ratio, it's just not in its simplest form anymore. So we can multiply both of these sides of the ratio up by 2, and now I'm going to have an answer of 14 to 8. So the ratio of houses to flats, 7:4, can just be rewritten as 14 to 8. And then we have the ratio of flats to bungalows, 8:5. So now we can simply add in the bungalows, which is still, if when there's 8 flats, there's 5 bungalows, like so. So now we have a ratio of houses to flats to bungalows, so 14 to 8:5. So then the ratio of houses to bungalows, in this case, we can just read off, taking out the 8 of the flats, we have as 14 to 5. And we are told that there are 50 bungalows in the village and asked how many houses there are. So now we can just scale up this ratio. So if we have 14 to 5 and we want 50 bungalows, we need to take this ratio and multiply it by a factor of 10. So we've done the bungalows side, and now we're going to do the houses side, and that's going to give us a ratio of 140 to 50. So when there are 50 bungalows in the village, there are going to be 140 houses. And there we've answered the question. So there are going to be 140 houses in the village. And we've gotten the marks here, firstly, for working out this first ratio. So basically relating houses to bungalows in this ratio here. And then the second mark is going to be for multiplying it up by a factor of 10 to see how many houses there are going to be when there are 50 bungalows. And then the third mark is for stating the correct answer of 140 houses here in this instance. Here we're told that Renee buys 5 kilograms of sweets to sell and that she pays £10 for these sweets. We're also told that she puts all of the sweets into bags and she puts 250 grams of sweets into each bag. And then she sells each of these bags for 65 pence. And we're also told that she sells all of the bags of sweets, all being an important word here. And we're asked to work out her percentage profit, so the percentage profit that she made by selling these sweets if they cost her £10 to buy. So with questions like this, we're given quite a lot of information. So I always find it really useful to go back and look through it and then write out any of the key facts that we need to know. So I can see at the top that we have 5 kilograms of sweets, so 5 kilograms cost her £10 to buy. We then have, she puts them in bags of 250 grams, and they are then sold for 65 pence. And then we're looking to work out the percentage profit from this, so that's all of the key numerical information that we are given. So initially here I'm realising that we're working with a couple of different units. So we have this value in kilograms and this one in grams. So it's going to be useful to convert these into the same form, and it's probably going to be easier to convert them both into grams here to avoid having any decimals. So I could do this already. So if we have 5 kilograms, to convert that into grams, we're going to multiply it by 1,000 because it's 1,000 grams in a kilogram. So 5 kilograms is going to be 5,000 grams, and then that's going to cost her £10 to buy. Similarly here, we have one of the prices in pounds and then one in pence. And again, it's probably going to be easier to convert into pounds here because pence is going to be a bit tricky to work with because we're going to have such large numbers. So if I take 65p and we want to convert that into pounds, we divide it by 100 because there's 100 pence in a pound, and that gives us basically 0.65 pounds. So 65 pence, just written in pounds, it's a bit easier to work with for us. So initially here, I'm going to start this question by working out how many bags of sweets she sold. We need to work out how many bags she sold to work out how much she made, how much money she made from selling these bags. So if she has 5,000 grams of sweets and each bag has 250 grams in, to work out the number of bags sold, we're going to take this 5,000 and divide it by 250. So how many lots of 250 gram bags can go into 5,000? And 5,000 divided by 250 is going to give us an answer of 20 bags. So she's sold 20 bags of sweets. And now we can work out the cost of these 20 bags of sweets to work out how much money she has earned from selling these sweets. So we take the cost of one bag of sweets, which is 65 pence, which we converted into 0.65 pounds. And then we can multiply that by these 20 bags. So how much did 20 bags cost? And that gives us an answer of £13. So basically, she sold her sweets and earned £13 from it. She's had £13 given to her for these 20 bags of sweets. We can now go on a bit further and see how much profit she's made. So if she has made £13 and spent £10, the profit is going to be equal to the difference between these two. So in this case, we're going to have 13 minus 10. So she's made a profit of £3. And we're asked to work out her percentage profit here. And the way of doing this is going to be by taking her profit, so the numerical value for the profit, dividing it by the cost, so what she spent, and then multiplying that by 100 to turn it into a percentage. So in this case, we're going to have the £3 profit, which is out of an original £10 that she spent on the sweets. And then we multiply this up by 100 in order to get this as a percentage. And once we calculate this, we're given an answer of 30%. And that is going to be the value of her percentage profit. So the percentage profit she's made on the original £10 she spent on sweets. And that's going to bring us to our final answer, which is the 30% that we've calculated here. So if I go back and look at how the marks were awarded, firstly, we have the mark for working out the number of bags sold, so the 20 bags. And it's always a good idea to kind of write out what we're doing in each step. So we have bags sold here and then the cost of the 20 bags, just so it's really clear what we're doing along the way. The second mark's then going to be for working out the cost of these 20 bags, so £13. And then using this to work out the difference, the profit, and then basically calculating the percentage profit here. And then the final mark is an answer mark just for getting the final correct answer of 30% here. So here we have that a cycle race across America is 3,069.25 miles in length, and Juan knows his average speed for this previous races is 15.12 miles per hour. And we're told that for the next race across America, he will cycle for 8 hours per day. And we're then asked to estimate, being the key word here, how many days Juan will take to complete the race. So a really key point here is that we're working with an estimation of the number of days. So we're not going to be actually calculating the exact number of days. We're going to be using rounded values and values that are going to be easier to work with to work out these number of days. So to start here, I'm going to start by rounding these values to some sensible kind of numbers that are going to be a lot easier to work with and provide a good estimate for me. So, if I take the 3,069.25 miles, a sensible estimate for this would be something probably to one or two significant figures, but because this number is so close to 3,000, I'm just going to round it down to 3,000 miles. It's a really nice whole number and it's going to be really easy to work with later on in the question. We also then have 15.12 miles per hour. And similarly here, this is very close to a whole number, very close to 15. And if I look at 3,000 miles and 15 miles an hour, these are really nice numbers that are going to work well and work together in these calculations. So I'm going to round this one to 15 miles per hour. I know the average speed and I know the distance, and I'm looking for time so that I can work out how many days it's going to take. So if I get my speed, distance, time triangle to work out how to calculate time, so we have distance and then we have speed and time at the bottom of the triangle, like so. And if I want to calculate time in this instance, I simply do distance and then divide that by the average speed in this case. So the distance I've rounded this distance to a distance of 3,000 miles, and then I'm dividing that by the speed, the average speed, which I've rounded to 15. And these numbers are going to work really nicely together, so we know we've chosen good estimates for these. So then I can take this and calculate this, and it comes out as an answer of 200. And the units here, if we have miles here and then miles per hour, the miles cancel out and we're basically left with 200 hours. We then need to work out how many days this is going to take Juan, and if he is doing 8 hours of cycling per day, then we can simply take this 200 and divide it by 8 to work out how many days it's going to take with 8 hours of cycling each day. So 200 divided by 8 is going to give us an answer of 25. So 25 days is what it's the estimated value that it will take to complete this race. And that's a good estimate. We could have used different numbers throughout the question. You could change them slightly and still get to a reasonably similar answer, but we need to make sure that we do estimate this and don't calculate it accurately, because we would not obtain the marks here for that. So the marks are distributed firstly for basically doing the time calculation, so the 3,000 divided by the 15, or some similar values, so some kind of distance over speed. And then the second mark is for dividing this down by 8 to work out how many days it should take if we're doing 8 hours of cycling a day. And then the final mark is for a correct final answer, which it could be a range of different things depending on which input values you've used. I'm now told that Juan trains for the race. The average speed he can cycle at increases, and it's now 16.27 miles per hour. And we're asked, how does this affect your answer to part A of the question? So in order to work this out, I'm going to go back and have a look at the equation that we used. So I used the fact that time is equal to distance over speed. Now we're told here that the average speed, so the speed, the S in this equation, is going to increase after his training. And an increase in speed, in this instance, is going to cause a decrease in time, because time and speed are inversely proportional. So time's proportional to 1 over speed. So as speed increases, time's going to do the opposite and decrease. So if less time is taken to complete this race, and in the previous part of the question we were working out the number of days it would take, doing 8 hours each day, if less time's taken when dividing this by 8, we're going to require less days to complete the race. So to get the mark here, you simply need to write the fact that less days are required. There's no explanation needed here, but it's always good to understand the reasoning behind the answer and see how this works, linking back to the equation. Alternatively here, we could have gone down the estimate route and said that 16.27 could still be rounded down to 15, like we did in the previous part of the question, and because we're working with estimates, this wouldn't actually affect our answer. That would also gain us the mark here. So either way, going about this question would gain us this single mark and bring us to the end of this question. So here I'm showing a solid square-based pyramid, which is the diagram below. And I'm told that the base of the pyramid is a square of side 6 centimetres. So I can see that here, this length is 6 centimetres, and then this length, and this length are also all 6 centimetres because the base is a square. I'm then told that the height of the pyramid is 4 centimetres. So I can see that this line here, from the centre of the base to the top of the pyramid, point V, is going to be 4 centimetres, that distance there. And finally, I'm told that M is the midpoint of BC and VM, and it's equal to 5 centimetres. So this is BC, and then VM, the line, is going to be equal to 5 centimetres, and M is this midpoint on BC. So we're then asked to draw an accurate front elevation of the pyramid from the direction of the arrow. So this is the direction, we're going looking at the pyramid in this direction, and we're asked to draw what it would look like. So we're basically going to be seeing one face of this shape. We're going to be seeing the front face. And I know that the length of the base here is going to be 6 centimetres, and I'm going to see this. This is going to be at the bottom of the front elevation. So I can draw a 6 centimetre line at the bottom, and if I take each small square to equal 1 centimetre, we have a 6 centimetre line here. I can label that one up. And then if I look at the diagram, looking from this direction, this face and the face obscured here, as well as the back face, are all going to be obscured by this front face that we're looking at. So at the front, in the front view, we're simply going to see this triangle here, AVB. That's all we're going to see looking at this square-based pyramid from the front. So we're basically going to be looking at a triangle. Now the height of the triangle isn't going to be this 5 centimetres. That's a diagonal height across this distance. It's going to be this 4 centimetres here, which is the distance V is from the line AB vertically. So V is 4 centimetres vertically above the line AB. And V is going to be halfway in between A and B horizontally, so 3 squares in between. So I can mark that point up. And then it's going to be 4 squares above. So 1, 2, 3, 4. This is the point where V is going to sit. And then I can just attach these points to this top of the triangle. And it's going to leave us with an isosceles triangle. So this length down the centre is going to be 4 centimetres. So it's an isosceles triangle that we will see with a base length of 6 centimetres and then a height of 4 centimetres. And that's going to gain us both of the marks here for understanding that it's going to be a triangle firstly, and then for getting the correct side lengths and orientation of the triangle. And now I'm asked to work out the total surface area of the pyramid. So I can see from the diagram, this pyramid is made up of its square base, so this face which is on the bottom, and then 4 identical triangular faces, which are all going to have the same area. So the surface area here is effectively one lot of the square base, and then we're going to be adding on 4 lots of these triangular faces because there are 4 triangular faces. And then I can start here by looking at the square base, as it's going to be easier to work with. It's AB is on length 6, BC is also 6 centimetres, they're all going to be 6 centimetres. So the area here is simply going to be 6 multiplied by 6, and that gives us an area of 36 for the base. And now we need to add on 4 lots of the area of one of the triangular faces. So if I redraw the diagram of one of these triangles, I can then take the base length, so 6 centimetres here, and then this length of the triangle. Now this isn't going to be the height of the pyramid, it's not going to be this 4 centimetres, it's going to be the distance between the top of the triangle and the midpoint on its base, so the distance VM, which we're told is 5 centimetres. So I now know that this one's 5 centimetres. Now the area of a triangle is going to be a half base times height, and in this case it's going to be a half times the base, which is 6, times the height of the triangle, which we've calculated to be 5, and that gives me an answer of 15. So now I have the area of the square base and an area of one of the triangular faces. I can simply add them together, so I have the 36 for the square base, and I'm going to be adding on 4 lots of these triangular faces, the area of that, so 4 times 15, and that's going to give me 36 plus 60, which gives me a final answer of 96. Now this question is worth 4 marks here, so it's going to require quite a bit of working out. And as we can see, in the question, we are given the units for each of the lengths. And there's no units predetermined in this question. So in order to obtain the last mark, we're going to have to work out the units. And we're working with area, so surface area, and that's going to give us a unit of something squared, and here we're working with centimetres, so I've done 6 times 6 centimetres multiplied by centimetres, which is effectively what I've done, is going to give me the unit of centimetres squared, which is the unit for area in this case. So to give my final answer and gain all 4 of the marks, I'm going to write 96 centimetres squared. So if I go back through and see exactly where I picked each of the marks up individually, the first mark would be for working out the area of one of the triangular faces, so getting that 15. Secondly, for then working out the total surface area, so by taking the 4 multiplied by 15 and adding on the 6 multiplied by 6 to get this surface area for attempting that. And the third mark's for obtaining the correct answer of 96, so this numerical answer here, that gets me the third mark. And then the final mark is for the units. Putting the units on the end, the centimetres squared, gains the fourth mark in this question. So here we have a pattern which is made from 4 identical squares, and we're told that the sides of these squares are parallel to the axes. And we can see that in the diagram below. So we have these sides of all of the squares which are going to be parallel to the y-axis here, and similarly these sides of the squares which are parallel to the x-axis. If we then go on, we're told that point A has coordinates 6, 7, and we can see point A here on the diagram. It's in the bottom left corner of the bottom left square of the diagram. And we then have point B, which is at 38, 36, which is at the top right corner of the top right square of this diagram. So these 2 points are the furthest away they could possibly be on this diagram. They're on opposite corners of the pattern, on as far away as they can be while touching the squares. We're then told that point C is marked on the diagram, and we're asked to work out its coordinates. So point C is here in the centre of the diagram. Now initially here, I'm thinking we're working with these 4 squares, which are all identical, and we can work out the distance between points A and B, and we could use this to figure out the side length of these squares, because we're going to need to know the side length to work out where C is in comparison to the coordinates of A and B. So we could either do this by looking at the x-axis or at the y-axis, but here I'm going to take the x-axis as my example. So I want to work out the side length of a square. So if we look across the x-axis, point A rests here at 6, and then point B, we trace that down, we're going to be at the x-coordinate 38. Now in between A and B, if we go across the x-axis, we have 4 complete squares, 4 complete side lengths of this square. So if we take the difference between these x-coordinates and divide it by 4, we're going to get the side length of 1 square. So I can take the difference by doing 38 minus 6, which gives me 32. And then I need to take 32 and divide that by 4 to give me 8 for the side length of 1 square. So each of these lengths are going to be 8. And because they're squares, we also know the vertical lengths are going to be 8. So this length here. Now we can use this to work out both the x and y coordinate of point C. So I can see that point C is going to be 2 complete side lengths away from point A and point B if we're going on the x-axis. So if I take the x-coordinate of point A, which is 6, I can then work with this. So I'll take the 6, and I now need to add on 2 lots of 8 in order to go across the x-axis to get to the point C to find C's x-coordinate. So I'm doing 6 plus 8 plus 8, and that's going to give me 22. So I've gone from point 6 across 8 and across another 8, and that gives me the x-coordinate of C, which is at 22. So I can write that in the box as I've already calculated the x-coordinate of 22 here. Now similarly, for the y-coordinate of C, if I look at the diagram again, from point B this time, if I go down 2 complete squares, 2 complete side lengths, I'm going to get to the y-coordinate of point C. So I need to take the y-coordinate of point B and subtract 2 lots of 8, so 2 side lengths from that. So the y-coordinate of point C, I'll take the y-coordinate of B which is 36, subtract 8, and subtract another 8, and that's going to leave me with an answer of 20 here to put in as the y coordinate. So now if I go back and have a look at how the marks were awarded, the first mark here was for finding the width of the diagram, so the width of these 4 squares by doing 38 minus 6 to get 32. Similarly, I could have found the height to get this mark, but working with the width just seemed a little bit easier in this case. I then get the second mark for dividing this by 4 to find the side length of 1 square. And the third mark would have been for then calculating the x-coordinate correctly using this side length of 8. And the following one for finding the y-coordinate correctly from counting down from the y-coordinate of point B. And then the final of the fifth of the 5 marks is going to be for the final correct answer given in the box as 22, 20 for the coordinates of C. So here I'm asked to, on the grid below, draw the graph of y equals 1 minus 4x for values of x from minus 3 to 3. Now for questions like this, as you can see, I've already drawn out a table because when you're working with set values of x and you're trying to plot a graph, the best way of going about doing this is by writing out a table of values and plotting the points so that you can draw a straight line through them. So we have x values from minus 3 to 3, so minus 3, minus 2, minus 1, 0, 1, 2 and 3. And then we can work out the y values by substituting the x values into this formula. And then we can just plot the points that come up in our tables and draw a line through these points to draw the graph of y equals 1 minus 4x. So if I take my table and have this top row having x values and the bottom row having y values, I have x values from minus 3 to 3, so minus 3, minus 2, minus 1, 0, 1, 2 and 3 are all going to be the x values. Now for the y values, I'm simply going to use this formula, this equation, and I take my x value and I substitute it in. So for example, for the minus 3 to start with, we have y is equal to 1 minus 4 lots of x, and x is minus 3, so 4 lots of minus 3. So y is equal to 1 minus 12, which is equal to 1 plus 12, because the minuses cancel out, and give me an answer of 13. Then I'd substitute 13 into here. And now I know that I have to plot the point on my graph, minus 3, 13. That is going to be a point on my graph. So I can do the same thing. So for minus 2, 1 minus 4 lots of minus 2, and that gives me an answer of 9. For minus 1, I'm going to get an answer of 5. 0 is going to come out as 1, as that's the y-intercept of the graph. So that's going to be the plus c part, which is 1 in this equation. For 1, I get minus 3, minus 7, and then minus 11 here. So now that I've got all of these points, I can start plotting them on my graph. So when x is minus 3, y is going to be 13, and I can find that point and plot it with an x on my graph. For minus 2, it will be 9. So similarly there, minus 1 is 5, 0 will be 1, and you can already see the line emerging. So 1 will be minus 3, 2 minus 7, and finally 3 minus 11. And as you're going, you should see all of these points are going to form a straight line. I can then simply take my ruler and I'll draw a line through all the points, going through all of the points, and that's my line of y equals 1 minus 4x. So as for how the marks are going to be awarded here, I'll get one of the marks for correctly stating or plotting 2 of these different points. So I could state the coordinates or plot 2 of these points correctly. I'd get a second mark for having a correct straight line segment that's going to go through at least 3 of the points. So a straight line needs to go through 3 of these points that are correct. And I'd get the third and final mark for having a completely correct straight line between the x values of -3 and 3. So in this question, I'm going to be working with column vectors and multiplying and adding them. So initially here I have A, which is 5, 2, and B, -1, 7. And I'm simply asked to work out 2A plus B as a column vector. So here I'm going to be needing to work out what 2A is so that I can just add it onto B to get the final answer. And with column vectors, I can simply either multiply A by 2, so find 2 lots of A, or just add 2 lots of A, so add A plus A just to get 2A. But here, if I'm multiplying a column vector by a number, I'm just going to be scaling it up by a factor of 2. So I can do that to the top and bottom. So 5 multiplied by 2 and then 2 multiplied by 2 is how I'm going to achieve 2A, so 2 lots of this A. And that's going to give me a column vector here of 10, 4. Now that I have 2A, I need to add on B. So I can take what I have for 2A, so 10, 4. And I'm adding on B, which is -1, 7 here. And I'm working with column vectors, so I can simply add the numbers at the top and the numbers at the bottom separately, and they'll get me the correct answer for the final column vector here. So it's the same as saying 10 minus 1, and then 4 plus 7. So that gives me a final answer of 9, and then 11 here. And then I can substitute that back into the box here to gain my final mark. So the first mark here has been awarded for manipulating the vector A and multiplying that by 2. So for this stage of the working here, just multiplying the top and bottom both by 2. And then the final mark is for coming to the correct final answer here. It's just a 2-mark question, and it's quite easy to pick up both of the marks as long as you know how to work with vectors and multiply and add them.